Next, let's establish the identity that cosine of alpha minus beta over sine of alpha sine of beta equals cotangent of alpha cotangent of beta plus 1. This is example 6. So I'm going to work from the left, right, and prove what I have on the right. So if I have cosine of alpha minus beta over sine of alpha sine of beta, I can rewrite this as, using this rule, cosine of alpha cosine beta plus sine of alpha sine of beta all over sine of alpha sine of beta. Now what I can do is I can pull this apart. So for instance, if I had 2, this doesn't show up very well. Let's change colors. If I had 2 plus x over x, I could rewrite this as 2 over x plus x over x, and this would simplify down to 1, right? My x's cancel out. So let's do the same thing over here. I have cosine of alpha cosine beta over sine of alpha sine of beta. What I'm doing is I'm pulling this fraction apart, plus sine of alpha sine of beta over sine of alpha sine of beta. These are going to cancel out, right? And I am left with 1. So now I have cosine alpha sine alpha, let's pull this fraction apart, times cosine beta sine beta plus 1. Well, what's cosine of alpha over sine of alpha? That's cotangent of alpha. And what's cosine of beta over sine of beta? That's cotangent of beta plus 1. So we have proven this identity. So for our third theorem, this is the sum and difference formula for the tangent function. So if I have the tangent of alpha plus beta, that's going to equal the tangent of alpha plus the tangent of beta over 1 minus tangent of alpha tangent of beta. And if I have tan of alpha minus beta, that's going to equal tan of alpha minus tan of beta over 1 plus tan of alpha tan of beta. So let's use this to solve the following. Let's establish the identity that tan of theta plus pi equals tan of theta. And you should think in your head already, oh yeah, this has to be true because the period of the tangent function is pi. But we're going to prove it mathematically. So if I have tan of theta plus pi, we can rewrite that as tan of theta, we're going to use this top one, plus tan of pi over 1 minus tan theta tan pi. So tangent of theta, we don't know what theta is, and that's okay. But tangent of pi, well, if we look at pi, that's 180 degrees. That's when x is negative 1 and y is 0. So my tangent of pi is 0. So I have 1 minus tan of theta times 0. Because we're multiplying by 0, that's going to go all the way to 0. So I have tan of theta over 1, which is tan of theta. Now, when we're establishing identities as we're using substitution, things should get simpler. So in this next example, although you might think, oh, I should totally use the tangent function. Well, I started to do that and it gets really, really gross before it gets any better. So remember that we can rewrite tangent, and you can still use this identity, as sine of theta over cosine theta. And that's what we're going to do to prove this identity. So I have tan of theta minus pi over 2. I'm going to rewrite this as sine of theta minus pi over 2 over cosine theta minus pi over 2. And then I'm going to use the difference formulas, difference identities. So I'm going to take sine of theta cosine pi over 2 minus cosine theta sine of pi over 2, all that over cosine theta cosine pi over 2 plus sine theta sine of pi over 2. Now I don't know what theta is, but I do know quite a few things. So first, I know that cosine of pi over 2 is 0. So these two terms are going to go away. And I know that sine of pi over 2 is 1. So I'm going to have negative cosine of theta times 1, which is just itself, over sine of theta. Well, cosine over sine is cotangent, so I get negative cotangent of theta. So we establish the identity. Let's work through our last example. So I'm going to find the exact value of sine of arc cosine of 1/2 plus arc sine of 3/5. So let's talk about some stuff that we know about inverses. So if I have cosine inverse of 1/2, we'll let that be alpha. That means that cosine of alpha equals 1/2. And if I have sine, arc sine of 3/5 equals beta, we're going to let this be alpha plus beta. This tells me that sine of beta equals 3/5. So now if I write this as sine of alpha sine of beta, that's going to give me sine of alpha cosine beta plus cosine alpha sine beta. Well, I know sine of beta and I know cosine of alpha, but I need to find sine of alpha and cosine of beta. And we're going to do that using what we know about circles. This is what we got to find. So remember that cosine is x over r. So I have x squared plus y squared equals r squared. I have x squared plus 1 squared equals 2 squared. So I have x squared equals 3. So x equals the square root of 3. Nope, I didn't just mean to solve for x. I meant to solve for y. Right? I knew my x, but I didn't know my y. So I get y equals square root of 3 because cosine x over square root of 3. That means sine of alpha is going to be the square root of 3 over my radius, which is 2. And I need to think about what quadrant I'm in. Remember that cosine, arc cosine is between 0 and pi. So that means my y value is positive, so we're okay. So now I know sine of alpha. Next, I got to find cosine of beta. I know x squared plus y squared equals r squared. Here's my y. Here's my r. So I have x squared plus 3 squared equals 5 squared. Now you guys should remember, hopefully from geometry, and you could not have to solve this all the way, that there's a special right triangle called the 3, 4, 5 right triangle. So that's a nice little shortcut for you to remember that x is 4. Otherwise you could keep solving. I have x squared plus 9 is 25, x squared is 16, x equals 4. And we remember that sine, arc sine, is between negative pi over 2 and pi over 2, so my x is going to be positive. So cosine of beta is 4 over 5. Now I can solve this, right? I'm substituting in. So if I have sine alpha plus beta, that's sine of alpha cosine beta plus cosine alpha sine beta. Well, sine of alpha is square root of 3 over 2. Cosine beta is 4/5 plus cosine alpha, which is 1/2, times sine beta, which is 3/5. So I get 4 square root of 3 plus 3 over 10 is my final answer.